Hey, this is Mr. Soy, and today we're going to take a look at algebra tiles. In particular, we're going to be looking at each of the tiles and writing down what exactly the area and perimeter is for each one. Later on, we're going to use these tiles to build rectangles, which allow us to do area statements, which are a critical part of our algebra that we're learning this year. All right, we're going to take a look at the first one here, which is x square tile. And the x square tile, if you look closely, the area actually is written in the tile itself. Same with this one, this one, this one, this one, and that one. So we can immediately write down the area of the x square one in the following way. The area for the x square tile is simply x squared. Now the reason it's x squared is because, one, it's a square and the side lengths of the square are all x. And as we know, when I calculate the area of a rectangle, I can multiply the base times the height to get the area. In this case, x times x gives me x squared. We can also use the fact that with each of the sides equal to each other, that we can find the perimeter easily by simply adding up the value of each side. So the perimeter for this one is equal to 4x. 4 sides, each side is x units in length, so our perimeter is 4x. Let's move over here to this tile here, which is the x tile. And again, we can find our area immediately since it's already labeled inside the actual rectangle itself. So our area in this case is going to be equal to x. And that means this side and this side, if you look closely, you can see that they would line up with the other x square tile exactly. So those are side length x. And then we haven't talked about it yet, but this, on those two sides, each of those have a length of 1, which would match up with the small 1 tile we have right down here. And so now we can actually calculate the perimeter of this particular tile by adding up those side lengths. And when we do, we end up with 2x plus 2, where I have two sides that are x and two sides that are 1. Add those together, I get 2x plus 2. Notice we're starting to look at these things in terms of an equation, which is exactly what we want to do, because eventually we're going to be building rectangles out of these and finding the area and the equations in what's called an area statement. Let's move over to this next one. This is the xy. And the interesting thing about this one is that we have essentially side length x and x here, and then that would make this and this y, and that would match exactly down here to the sides of the y square. This y here would be the same as that one right there. All right, well, now we can find the area for this one. It's already given to us, so area equals xy. Base times height would be y times x, and we would write that as xy. And then our perimeter we can write out. That would be equal to 2x plus 2y, where we have two sides that are x length and two sides that are y length. All right, well, now that takes us down here to the y squared, and pretty easy to label this since it's a square. We know that each of the sides then must have the same length. So in this case, they're all y. And again, the area is actually given to us by the name of the actual square. In this case, y square. That's our area. base times height, y times y gives me y squared. And then our perimeter, well, just like the x square, that's going to basically be 4 times the side length y. And then similarly, over here we've got side length y, and then that 1 and 1, just like we had with the x tile. So this is the y tile. And again, we can find our area just by the name itself. Our area is y, which is 1 times y, base times height. And then our perimeter, just like with the x tile, is going to be equal to 2y plus 2, where we have 2 sides that are y, 2 sides that are 1. And that's how we would write the perimeter. And that takes us to this very last tile right here. This one, the 1 tile, we can see the area inside, which is 1. And in fact, also, the side lengths are all 1, since it's a square as well. Base times height, 1 times 1 gives me the area of 1. And then our perimeter, well, we just add up the side lengths, 1, 2, 3, 4, and that gives us a perimeter of 4. So understanding the side lengths of these algebra tiles and the areas of the algebra tiles, and then the perimeters, which allow us then to understand how we can add these sides together and write them in an equation form, are important for when we move into the area statement when we're looking at algebra tile rectangles and finding the area. Thanks.